Hey everybody, this is Larry. This is me going Q4 of the weekly contest 321 on Leetcode. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think. And this problem is, I think I said in the wrong order, count subarrays with median K. So this one I had a lot of struggle with. I was doing very well until the last minute, and I think near the end especially put too much pressure on myself and kind of just submitted and kind of gave away a couple of wrong answers. Though I think one of the wrong answers I probably needed it, but the other one maybe not as much. Okay, so the idea behind this problem is actually kind of so the way that I did it is not the way that I'm explaining it, to be honest. But I think after thinking about the problem right after the contest, I was able to kind of visualize a different thing. And the idea that I'm trying to that I'm going to explain is what do they call it? Like target some dynamic programming or something like this. I'm putting up the painting or the paint, but basically, really, and let me set up the painting, and I'm going to just give an example, right? And here we don't really have to. I mean, they kind of set up the problem a little bit differently, but I'm just going to write things in terms of x and then just like plus minus, right? Meaning that it is greater than or less than or equal to whatever, right? And I don't know why I wrote comma, but something like that, right? And really, I kind of was thinking about something way more complicated, but the way that I would attack this problem, and I think that's what a lot of people did to get a very high score. And I thought about it. I was like, oh yeah, if I had this visualization or mental framework, even though I got there eventually in a kind of a different way, and we could talk about that in a little bit. And you can watch me sub it live during the contest. I don't think that's the best way to go about it. But the idea here is that so we have some prefix of this, right? That's a terrible arrow thing. So let's just say we have some prefix of this and some suffix of this, right? And basically the idea is that we try to find the counts in which, that means that we have this subarray where x is the median, right? You get the idea. And of course, what does that mean if you want to kind of like how do you rephrase this, right? It means that basically that in total, in these pluses and minuses, and we'll go over the special case in a second, but that means that the equal numbers of pluses and minuses, or in this case, I think there's one more plus than minus or something, yeah. Or plus one or something, I don't know. Right, oops. And this is of course the case where you have even number length on the subarray, right? So once you kind of reduced it to that, it becomes a little bit easier if you kind of think about that. And of course, you have to do the prefix suffix thing going from the x outwards, right? And basically, you can run some examples by yourself, but let's just say you have one at a time, right? So let's just say on the left side you have here. Let me erase some stuff real quick. Let's say you're here, right? You have one plus on the left, right? That means that you're trying to get to one minus on the right. Well, yeah, how many ways are there to get one minus on the right, right? Well, this is one case because you have two minuses and one plus. I think this is also the case where, and so forth. So basically the idea is, of course, let's just say we have one plus, we try to pre-process the right so that we find the number of cases where there's one more minus than the other. And that's basically the idea. And you can also process the right in the same way. Let me change the color real quick. And you can process the right on the same way by that. Okay. And you could kind of use your own language, but basically now you go, okay, after this plus, there's one more plus, and then after this minus, there's 0 more plus. After the second minus, we have -1 more plus, -2, -1, and then -2 again, right? And then here, and then now on the left side, we go, okay, so this is 1. So this 1 matches these 2. So that means that there are 2 ways to do this. And of course, it also matches this 0 because of the even number sequence thing, right? So that means that here we could do it in 3 different ways. And then now we go, now we go move 1 to the left. And then here we have 1 more minus. So that means that, let's just say this is 0 because now we have number equal number plus or minus. And of course here you do another count. You do, okay, this is 0. Well, there's 1 0 here and also 1 -1 here, right? Or do we want -1 or +1? Oh, actually we want +1. So maybe I messed up something here before, but you get the idea. You just basically now going 1 more, this is another 1, and then you do the count again on the right side, and then so forth. And of course, now you repeat it for the left side, say, because just to make sure that you don't have to. Let me rephrase that. There are different ways to kind of do it, but some kind of combination allows you to kind of dedupe it in a good way, so that you don't. Basically, you just don't want to double count. That's all. But basically, that is the idea behind this problem, and the core idea behind that is, of course, the dynamic programming thing where you're trying to find number of subarrays where sum is equal to x, right? I think that's a problem on Leetcode, maybe even a couple of problems on Leetcode. I think that nowadays it probably is like a medium problem. So definitely practice that. But if you don't understand this explanation, if you work on that problem and maybe check out that video for that explanation, then you are able to kind of match it this way. So that's basically the idea behind this problem. And if you go through my live portion of this, you see that I kind of ran awry and I did a lot of things, but this is my actual code. So I count the delta left starting from inwards going to the left. This is the delta left, and of course I show the number of times I've seen and also start at 0. Put 1 count 0. We do the same thing on the right side, and then we just do a count here. So the way that I do the dedupe is that make sure that at least one of them, because I am looking for the negative version, because if you have 3 on one side, you want the -3 on the other to equal to 0 in the sum, and here you want to equal to 1 in the sum, because so that you have 1 extra positive, so that has medium, and the reason why I keep it I is greater than 0, so that we could do the other side and do the same thing without worrying about double counting. And in the end, I also count out the number of cases where there's zeros on both sides, because this isn't, these don't take care of it. And that's pretty much it. This is going to be linear time, linear space. I don't think I need, let me make it slightly smaller so you see everything. I don't think I need to go over that too much. I mean, there's a couple of arrays, there's a couple of linear things. And everything else is linear, right? So linear time, linear space. And that's pretty much all I have. And I really spent way too long on this one. You could watch me live next. You can maybe fast forward. I was playing around with a lot of different ideas of because another way that you could, I was thinking, I made a mistake really, because I thought, so the biggest mistake that I did was that I was trying to be too clever, and I thought there's some sort of pigeonhole principle, because I kind of did the optimization before I needed, and I kind of got stuck between a few ideas because of that, and it took me a long time to reset it into what you have here today, and kind of get my mind into be like, no, your original idea was wrong. So I think I just kind of loop it that way, and you can take a look to that now. Maybe I started programming a little bit too quickly instead of proving it, and it happens. But yeah, let me know what you think, and you could watch me sub live in a contest next now. Okay, good. Didn't load. Okay. Whew. Okay, 1 to n is a permutation, and an integer k. Return the number of non-empty subarrays and num-sample median. equal to k. So okay, so don't know how to start, but let's think about it. Do some, well, okay. Someone already got it though. It's too fast to update. Let's see. So we want 4. What does that mean? So it means itself. Okay, so that means 4, 5. I mean, there can only be a most n of them, right? So we start with 4, we add the 5. Let's see. 4, we add the 5, we add the 1, and then can we add a 2? The answer is no. So, then is it always true? Can we always add either left or right? What if the 2 ways to do it, if they're both right, then that's it, right? So the only way that you can extend is with these kind of ad hoc problems. I'm not confident on or any ever. So, but yeah, the answer could be at most n. So, okay, nums at index of k, right? And then basically, okay. Oh, so I guess count is always 1 at least. So then, okay, just to work through. Left is 0 index, right is 0 index. Okay, is that? But that's not true, right? Or so that's not quite right. You can't. So because you can have something like 1, 2, 3, 4, or something like this. Let's say we have 6, 6. That looks like it would end it, but then we have 1, 1 in the other side. I mean, I'm not doing it. Then they would kind of match up, right? So I think it's a prefix something of numbers greater than and less than on the left, on the right. Maybe that makes a little bit better sense. The even numbers are always so odd, but people already got it, so people are very smart. So, okay. Okay, and then now on the left, we want the smaller and bigger. Okay. Can we do it that way? Okay, let's just say smaller left. I mean, I could probably put it in the same way, but I just want to do it this way. Index, right? Is it? Index minus 1. If nums I is less than k, then I mean, you could probably figure it out by itself, but yeah. Maybe off by 1, I think. Yeah. don't need it, just kind of make it easier to write. Okay. This is index 3, then 5 minus 1 is 2. Okay, that actually doesn't, we don't need to plus 1, I think. Maybe we, why not? Plus 1 and, okay, makes sense. Because I feel like I'm gonna make a mistake. I have to think about this. I don't know if this is actually strictly necessary. I think maybe you could do a set. I don't know if that's true. Okay. So then now, people get it already? Oh, people already got it. So then now, okay. Maybe we'll just do it again. So, and I think now we can actually just, this should be a set, actually. Maybe even, let's just do a set. And then now, oh wait, if they're a set, then it has all the things, right? So I don't even need this. This is just a number then, huh? Maybe. I don't know if this is true. I'm doing too many reductions. I should have maybe kept it dumb and simple, honestly. Or like, you know, the high machinery, but because then I might regret this later. Okay. And then now we can just do the math on this. Basically, so basically, okay, so let's say they're even, right? So we add min of small left. We might need it for the even number case. Maybe that's not true. Bigger right, smaller right, bigger left. So the min of them are basically they're equal. Is that true? No, I messed up, I think, because of the case that we had earlier. There's no pigeonhole thing. because in this case, then the left. Now all you need to know is the existence of 1, right? You don't need to know exactly that, whatever. Okay, in this case I do 1, which is kind of way wrong. Oh, you should just start with 1, so maybe that does make it right. And then now we want the even one, which is, so we want one number that's bigger, right? So then the odd case is I don't know, this feels very wrong though, and these cases don't really allow us to explore that, and this is just very wrong anyway. So but basically, for example, you want, well, 1 bigger, right? So this should give me 1. So oh, I see. Is that right? No, that's not right. Basically, you want odd number ones. Oh, did I? This is too hard for me, maybe. Wow, a lot of people got it, so clearly people really know how to do it. Maybe the way that I had it was right, because then I could just put force on it. I think I tried it to be too clever. Can I undo enough? Alright. Apparently I can. Okay, so now, okay. Let's see. So smaller left. Let me try to figure this out. 6. Right. So in this case, we have 2 smaller left, 1 bigger, and the right we have 2 bigger, 1 smaller. Okay, that's good, but I don't know how to do it. Or at least the odd number of it. So for example, we do. A lot of people got in this one, so I'm kind of struggling. It's 2 2 1 1. So I think the matching makes sense, but I don't know how to do the odd number ones. So it means that odd number ones are the, well, even number ones are the tricky one. Okay, so then 4 5. Okay, let's say we go to the right. We have 1 bigger. What does this mean? So we have counts equal to 1. We have left of 0. Bigger right of -1. Okay, and then now we're trying to do the math on the odd or the even numbers, right? Is this right? I don't know if this is right. I think this is right though. Or expected. Maybe? No, this should give me... Yeah, no, that should give me 1. But this should give me 2 for this. Why is it not working? And I guess it just put 0, so I don't know why. But smaller left. 3 to 1. Okay. Okay. Bigger right. Do I do this in a weird way? Why? Huh? How come this didn't get propagate? I minus index minus 1. Huh? This should propagate to the right, so that's a mess. Huh? Okay, I guess I just kind of... Oh, because I added an extra element. That's why. Okay, fine. Okay, so now I have the equal cases, but how do I do the odd case? And it could be like really odd, right? It could be like 2 on the left, 1 on the right, or something like this. Right. I guess we just have to do a for loop, maybe. In range of... If bigger right is greater than smaller left, right? I think I did this wrong. Because there is not necessarily a pigeonhole thing because you're adding more numbers. So I messed this up. This is not right. Huh. Wow, people are really... I think I just messed up. Okay. Okay, so I think I want the delta of them on the... Okay, I see. I hope I get this in time. This is kind of tough. Okay, and then now I see. And then, I mean, this is way silly, but okay. I mean, I could simplify this, but it's not. I don't know. Is this right so far? I want to do something like, I don't know if this is off by one, but yeah, if I think this is a good idea, but it's not quite right. I think I get it, though. This is very sad. Well, this is not quite right either. So for 3, so small, so -1, -1. Oh, if the delta is whatever, then you want the delta to be the opposite on the other side. Okay. This feels very sketch though. Now, also I don't know which way. I think we want the bigger side, so this may just be, this is very wrong, but so delta on the left. So left is more bigger numbers, so plus on the left. I don't like the way that I did this, to be honest. I'm just gonna do it this way and then do -I. Does that do anything? Okay. And then what we want now then is 1 more. Okay. So this is -1 on this side, I think. And then maybe that's good. I don't know. I'm not really confident about this at all. Let me YOLO submit. Okay. But I didn't want to spend 5 minutes debugging it. So now I think I have a good case to kind of build off. I think my idea is finally right though. So yeah, so the output is 1, expected 3, huh? Median, wait, K is 1, right? Did I misunderstand? Oh, it's 1, 4, and 1, 5. Okay, I see. So on the left, it's going to be bigger. So on the left, I really needed to do the one on the right as well, right? But I return only 1. So that was just not going to be right anyway. And I also need to do right of 0 as the increment, I think. I think that fixes some parts of this, but I also have to do it from the right side. And then I have to not duplicate it. Okay, I guess the way to not duplicate it is if I is greater than 0. I think this case was worth 5 minutes. I mean, I don't know, I probably could do better, but that's fine. Okay, I messed up. Left is bigger, so this would be 1. do I increment on 0? That means that it was just wrong to begin with though, so that's fine. But on the left, if I is 1, right? Okay, so on the left, let's actually might as well just print both. Okay, so left is 1, and then the right is -1, which is 0. That's true. But then why is this? Did I do this sign wrong? I wasn't sure about those signs actually, but okay, let's try again. I'm kind of tired. Come on, let me run the code. All right, let's give it a submit. I still think I'm in the right idea, but this is kind of sad. Wow, a lot of people got this one. Maybe this is sillier. I mean, I don't think this is that hard, but said the guy who can I get it right. So 6. I also print out way too much. Oh, I did this way really. Okay, so I have 7, but it's 13. So 6. How do you have 13? So left, 0 left is kind of weird, but is the delta the only thing that matters? I think so, yeah, because then it's 1, right? So, okay. How do I even debug this? How do you even get 13? There's not 13 things here, so do I have to multiply? Like, maybe min is not right. Is it? No. Because there are 2 ways to do it on the left side. Is this right? I mean, it's still got the first 3 right, but then the 10 is clearly really wrong. For 0, I think I need to do zeros. That's why as well. Now we overcount. Oh, because we have this 1. Come on, unknown error. Come on, friends, unknown error. Unknown error is kind of annoying. Okay. Now let's unknown error. How do they count these contests when you can't even run the thing? Okay, let's give it a submit. Okay, cool. 45 minutes. I mean, this is, wow. Wow, I mean, it is a disaster. People just really got it really quickly. And I have 10 minutes of penalty, so this is, yikes. No, I just saw Josh actually, but wow. I mean, I'm just catching my breath a little bit. Let me also rewrite this because I just am not happy about this at all. Let's see. Right. I mean, this is a ridiculous code, right? So actually, I did it the other way, I think. But yeah, I probably should have done better on this one. I think I jumped to implementation a little bit too early if I were to analyze this one a little bit. Because I don't know, maybe that's not true. But I really did not have an understanding of this problem. Yeah, I mean, this is a bit cleaner, but I mean, yeah, I don't know. This is just going to keep going down because so many people have gotten it. And so quickly, too. Wow. I mean, 4 minutes? Yeah, I mean, I guess it's not that surprising, but that's actually pretty good. I respect that. There are definitely a lot of things to put together. I don't know if it's a seen problem or known problem, but I enjoy solving it though, so I don't know. And I gave away 2 wrong answers because I think I just kind of rushed the end because I knew I was close and I knew that I was right. And then I mean I did min instead because I was stuck on the first way of thinking about it, and then yeah, I was stuck on the first way of thinking about it. Because I don't know. I think I was just confused a little bit. But this is a pretty problem. I really like this one. I think it's not as bad as I made it seem. I think it's not. Yeah, I think. But I think. Yeah, I mean, I think looking at it the right way, I know how to explain it in a video or something. But I definitely did not approach it from that direction. I think I was thinking of what was I thinking of? I don't know. I was thinking. Well, one is that I tried too much on the optimization. And I was thinking about some pigeonhole things that I kind of overthought myself. I think it was pretty straight. I mean, I wouldn't say straightforward, but it's not a bad problem. It's a good problem to work out. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this explanation, this contest, everything. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.